So here's what you might help you for tomorrow's lesson pula. Here's what may help you for tomorrow's class test, because I know that it's first time you're taking science class test. It is very scary. But you already done all the other class tests. Physics. No issue lah for you. Okay. So so quick overview about all the topics that you've covered so far. Okay, you already know. By the way, am I showing you the Jamboard? I just realized I talk. I don't know whether I'm showing you the correct. Thank you for your replies. Okay. All right. Okay, so you already know chapter 1 is about the physical quantities and all that, right? So you don't really need to focus so much for class test 1 lah, okay? I'll just let you know. Look, I don't give you tips, but I don't mind letting you know what to focus on. Okay, I'm not going to tell you what's going to come out, but I would hint to you lah. Okay, please focus on certain parts. All right. So just to let you know, chapter 1, don't focus so much on this. All right. In reality, overall, you do need to know, your 7 base quantities. You actually do need to know, like I asked you guys to do the homework, remember, where you had to write in, base units and stuff like that. This is basic stuff you need to know, but for class test 1, no need, all right? You don't have to focus on this, okay? So you must be aware as a physics student, but no need to focus on this, okay? So that might. So you just, I'll put KIV here. KIV means you keep in view. So don't need to focus on this, all right? So I want you to focus more on chapter 2 for your class test 2. Class test 1. So fast want to go class test 2 already. Chapter 2. Chapter 2, what have we covered so far? Right, we've covered linear motions. We've covered linear motion graphs. And we have covered free fall, correct? Yeah. So I need you guys to focus on chapter 2, okay? So all 3 are important. Okay, all 3 are important. So what I'll do is I'll go through some of the key things that you need to know lah for this, okay? So in terms of linear motion would be the calculations lah. Okay? Just go through again how to solve using the formula, but you don't have to memorize the formula, okay, class? So the formula will be given. If you check your Google Classroom, I already put a screenshot of the formula that is listed in the class test. Okay, you go and check. So the linear motion equations are A equals V minus U over T, V squared equals U squared plus 2AS, S equals UT plus half AT squared. No need to memorize. If you want to memorize, you're being a fool, because teacher already said no need to memorize. Okay? Okay? So use up your brain space for other more important stuff, okay? Yeah? So don't memorize, all right? Don't memorize. Okay. Just what you should know though, what you probably need to memorize is what each symbol represents, all right? Like what is A, what is U, what is V, what is T, what is S. If you don't know what they are, then that one you spend some, like just memorize, okay? But it's very easy. Remember, A is what? Acceleration. Okay, U is initial velocity. Okay, V is final velocity. T is time, S is displacement. Okay, and make sure everything is in SI unit. If some of you are still confused about acceleration and velocity and all that, yeah, displacement you should know is meters and time is second, of course. Remember that velocity is exactly like speed, all right? So that's why both of them are meters per second. Now, whether you write -1 or you want to write as meters per second like this, they are both accepted. Okay, both are correct. So it's either ms minus 1 or m/s. Okay, don't try to combine both. If you write like this, it's definitely wrong. All right, so don't do this. It's either or. Same thing with acceleration. Acceleration is meters per second squared. All right. So you write ms negative 2, or you can write m slash s squared. Either or, not both. If you write like this, no choice, I have to mark you wrong. Okay, cannot. These are completely wrong. All right. So in terms of how to use the formula, like I said, go back and look at the Jambots. Not Jambots lah. By right, you should have copied this out in your workbook. So go back and look at your go back like you already home. Go and look at your workbooks. And just see lah. Just recall how to substitute. Okay, like you see the questions, you just write down what is A, what is U, what is T, what is S, and then you just check the formula. Okay, which formula can I use? You sub in straight away. Okay, but remember that displacement, like this situation, right? Slide number 1. Remember that displacement is from the initial to the final. Okay, if so, I forgot to mention. You guys on the Jamboard you can go back to slide number 3. But this remember displacement is from initial to final positions only. Okay. Linear motion formula. I just want to check. Does anyone still have any issues using the formula? No, 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 no. Not difficult lah. Once you know how to use, right? Some formula given to you. Whoo! Wow, huge relief. Wow, don't need to memorize. Oh, happiness, right? Yeah. Okay. Anyway, so linear motions, I think not an issue. I'm going to go to the next slide. So go to slide number 4 if you're on the Jamboard with me, guys. Okay, linear motion graphs. Linear motion graphs. Okay. So one of the challenges, and I think this is a very challenging topic. I wish I could have spent more time on this. Unfortunately, because I had to make sure I covered the scope for class test, I couldn't spend too much time on this. So linear motion graphs, right? Remember, whenever you see the graph, the first thing that you must do is observe what is on the y and x axis. Okay. Remember, whenever you see any graph, not just physics, chemistry, bio, economy, you don't think economy, sejarah got no graph also. What others? Maths and maths all X Y only lah, no meaning one. Next time you take business, whatever, right? Always remember, first things you do, you always see what's on the graph. So, graph plot, see what's on the y and x axis. So you, in this case, we may have a displacement time graph. Sometimes they write it short form, sometimes they write in full. So just be aware lah. Okay. Displacement time graph, velocity time graph, or acceleration time graph. It is possible for physics SPM to give you any of these 3 graphs. So if you get confused right now, so I'll just again go through some reminders for how to remember the different answers. Okay, and there are many methods. You choose the method that works best for you. So let's talk about the first one, which is in terms of gradient and area under the graph. Okay, so remember that in general, let me write it over here. Gradient is y2 minus y1 over x2 minus x1. Okay, but tomorrow you won't be asked to calculate gradient. Not like for your. Are you gonna ask? I didn't ask. Ooh, cannot tell you yes or no. Sorry, I was thinking of the super big graph with graph paper. That's possible they can ask you to count gradients, right? But anyway, even the gradient they ask you to count also, they won't ask you to use this formula. This formula is normally used when you have an actual piece of graph paper, with the proper graph drawn to scale and all that. But for physics, you may have to count gradient, but you're not required to use this formula. Okay. So let me explain what I mean. Basically, gradient, right, because it's y over x, naturally it's the change in y over change in x. Okay? So you remember it this way. Because it's y over x, right, that means this one, for displacement time graph, gradient is displacement over time. Because of this displacement over time, it becomes meters per second, correct? So when you see meters per second, what is same as meters per second? Velocity. That's why this is equal to velocity. So you can either use the units to help you remember what the 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 value is equivalent to, or you just look at the formula. Oh, displacement over time. Displacement time is velocity, lor. If you're looking at the velocity time graph, this is meters per second, and this is second. That means the gradient is velocity over time. So velocity over time is like acceleration. If you look at the first formula on slide number 3, a equals v minus u over t, that's velocity over time, right? So that's same as acceleration. Or another way is to use the unit, meters per second divided by second. So meters per second divided by second, you will get meters per second squared. That's why it's the same as acceleration. Now, for acceleration time graph, gradient got no meaning, because if you try to count gradient, I'll just scribble here. Acceleration over time, there's no meaning, Even meters per second squared divided by second, you get meters per second cube. No meaning, so don't bother. Tapaya. So I'm just going to rub this off, because you're going to be like, teacher, what is that? And I'm going to tell you there's nothing. So what for we want to see got nothing, right? So we rub off, okay? But I will write the units here, lah. Okay. Then area under the graph. Area under the graph is like what depends on the shape. So remember, area, you must see the shape, whether it's triangle or rectangle or something. Let me just write in general first. Area under the graph, if this is a rectangle shape, area under the graph is A times T. Who's Dylan Wang? So anyway, area under the graph is essentially, if you, let's say, you can count rectangle, you can count square, you can count circle. That's not circle, but anyway, basically it's area of the graph is basically what's on x times y, just to let you know lah. So you can think of gradient as y over x. Area under the graph is actually whatever's on x times y, if you think about it, because if you have a rectangle shape, it's x times y. Even if, that you know, in case you're trying to process, but teacher, what if it's not rectangle? What if it's triangle shape? Who's that? Okay. No, as long as the name I recognize, I'm okay. If it's a triangle shape, even if it's half times x times y, but in terms of the quantities, half is a constant. So when you look at the x and y unit, it's still just meters per second squared times second. So that's why when we look at, even if there's a half there, we ignore the half when we want to consider the quantity, because half is not a consideration in terms of changing the quantity. I don't know whether you understand what I mean, but I don't want to go into that right now, because that's not relevant to your class test. If you don't understand, look, we'll talk about it another day, okay? So area under the graph, basically just think of it as x times y. That means area acceleration times time. So a times t is sort of like a modification of the acceleration formula. That's why this is equals to v. Or you can think of it as meters per second squared times second. That's why you can get meters per second. So that's why it's the same as velocity, okay? Meters per second squared times second. In terms of the velocity time graph, you can take it as area under the graph. I'll just write area, okay, as velocity times time. When you look at this formula, it's actually a modification of this formula. That's why this is equal to displacement. Or you can think of it as meters per second times second. That's why you get meters. Okay, so this, whatever I've gone through here is just to help you remember how to interpret the graphs. Another way, I'm going to go to slide number 5, guys. Go. Those of you on the Jamboard, you can join me on slide number 5. Another way is you just remember this. You can write this out if it helps. Displacement, velocity, acceleration. This L, oh my god, how to spell? Okay, let's try that again. Acceleration. Okay, so displacement is in meters, velocity is meters per second, acceleration is meters per second squared. Or you want to write it as m slash s meters per second and m slash s squared. Either one is fine. Okay, they're both correct. So you just pick one and stick with it. So remember, as m, then -1, -2 for the seconds. Okay, so when you move to the right, you would count the gradient. That means if you have a displacement time graph, then the question asks you count the velocity. That means you count the gradient of the displacement time graph. Understand? If you have a velocity time graph, the question asks you to count acceleration. You use the gradient to calculate the acceleration. But if they give you an acceleration time graph and ask you to count velocity, you count what? The area under the graph. That means when you move to the left, you're counting the area. Same if you get a velocity time graph, the question asks you to count displacement, you calculate the area under the graph. So remember that for gradient, right? Yeah, you do use the y2 minus y1 formula. You still kind of do. So whatever the graph is, right? Like let's say if you get like this kind of graph, say it's a velocity time graph. So when you calculate gradient, you can only count gradient for one part at a time. Okay, you only count the gradient for one part at a time. So you do use the gradient formula. So the gradient in this case would give you the acceleration. If the question asks you to calculate the displacement would you need to count the area under the graph. So depending, like let's say that means when you count area in the graph means from the graph to the x-axis. Okay, like look at the shape. Like this first part here, the shape is a parallelogram. Okay, second part here is a rectangle. Third part here is also a parallelogram. So you just remember you use your maths way lah. If you don't know how to count parallelogram, oh my god, teacher, I forgot the parallelogram formula, how die lah? Then you cut and draw triangle plus rectangle that one then easier, right? Then don't panic. Okay, physics is easier than maths. You don't worry. Okay, if you can do well in maths, you can do well in physics. Okay. So that's how you solve the question. Remember always to write the units for your answer. Okay. Linear motion graphs. I'm trying to remember what else you need to know. The shapes, right? All the curve shape. I think you refer to your refer to your workbook, the table on page I think 34. Is it the row by row one? Tomorrow's classes won't be so complicated lah, I think. I'm trying to remember your class test. I don't remember what's coming up for class test. Linear motion graphs, you think you're okay with it? Just remember lah, in general, that when I say things like like this, slide number 4, when I say things like gradient equals a velocity, everything that you can interpret from the gradient, that will be the same as that quantity you say is equal to. That means, like, let's say if it's a velocity time graph, I'm going back to slide number 6. If I say that the gradient is the same as acceleration for velocity time graph on slide number 6, like the first part is a positive gradient, right? Positive gradient means positive acceleration. Here is 0, right? I just look at X. I was trying to do a cross, but saying it because my head is saying it at the moment, but you can't see it on camera because the camera's not on. So anyway, this is positive acceleration. Positive acceleration because positive gradient. Okay, so positive gradient means positive acceleration. That's what it means. 0 gradient means 0 acceleration. Okay, negative gradient means negative acceleration. Everything you can interpret from the gradient, you apply it to the acceleration for this kind of graph. Everything you can interpret from the area of the graph, that is equal to the displacement. Okay, that's what it means. Okay, that's why, like, if you have a graph where let's say the graph is curved this way, you can see gradient is going up, so an increasing gradient. If it's a velocity time graph, an increasing gradient means it is an increasing acceleration, right? If it's the other way, if it's a decreasing gradient, then decreasing acceleration. No, sorry, I draw so small here because I got no more space. If I go to slide number 7, okay, same application for the other slide. Let's say if it's a displacement time graph, if you have an increasing gradient for a displacement time graph, this means increasing velocity. Okay, so anytime you want to interpret, first thing first, always look what's on the y and x axis. Okay, if it helps, let's say next time, let's say you got a question, let's say example, question gives us a displacement time graph, whatever the shape is, okay, whatever the shape is. So if it's a displacement time graph, you must remember, displacement time graph. If it helps, just take out your pencil and scribble at the side here, and then just write that, okay, the of displacement time graph means that the gradient is equal to the velocity. Then only you start solving the question. At least you write this down, then you are aware. Okay. If it helps, you write down the diagram on on slide number 5 somewhere. Don't write this and bring to class test tomorrow. That's cheating. Okay, that's cheating. You don't do that. After class test starts, then you scribble. That's not cheating. Okay. I have to say this very loudly. Okay. It's like how in real life exam, you go into the exam hall, you don't bring paper in. But the moment the paper starts, you start scribbling on the question paper, that's not cheating. But if tomorrow class test, you like, never mind, I think it's okay if you bring this along quietly and then you put it at the side. That's cheating, okay? That's cheating. Don't do that. Miss Ho will be very upset to know that you cheated. And then Miss Ho will sit in the corner and cry and then ask what has she done wrong. Velocity time graph. So if you have a velocity time graph, also the moment you see check first, velocity time graph, take your pencil and scribble somewhere at the side and say, okay, remind yourself that if it's a velocity time graph, gradient is equal to the acceleration, and the area under the graph, it would be equal, I'm just writing area short form, okay, because I know it's 839 already, I know it's going to be time. Area equals to displacement. So sometimes it helps, right, if you scribble this before you start solving, because if you already know, look, you guys, some of you already know, then no need to scribble, you can start solving straight away. But some of you, if you're afraid that you're going to get confused, always scribble at the side and then only read the question, because sometimes you may not need to use this information, but at least if you have it there, if the question does ask, at least you know how to solve correctly. You don't get confused. In case you blank, oh my god, I forgot, it's gradient, velocity, or acceleration. So at least you check first. Don't even look at the shape. You look at, this velocity time. You start writing down at the side here this information. Then at least then only you start solving the question. Start reading the question. Then it's easier for you to solve correctly. Okay. All right. Any questions? Okay. Moving on to slide number 8. Okay. Free fall. So free fall is the one where you FOC, buy one free one, no need to pay for it one. You want to fall down many times, don't worry, it's free. Except just go see the nurse after that. That one maybe you have to pay. Okay, so free fall calculations. If the calculations that what am I saying? Control A, delete. Okay, start again. Free fall. So free fall calculations is not something brand new. If you know how to solve linear motion equations, you can solve free fall, remember? The same formula, A equals V minus U over T, V squared equals U squared plus 2AS, S equals UT plus half AT squared. You use the same formula. So remember, I told you just now, must memorize the formula or not? Yes or no? No, yeah. So no need. So don't waste your brain space. I know you have to make space for sejarah stuff. Okay, you reserve those pockets in your brain for some sejarah bits, but please don't have to. Then whatever you want to memorize is the space meant for this. You go memorize sejarah. Okay. No need to memorize the formula. Please focus on application. So if you have to use this in free fall calculations, remember that A must be equal to the gravitational acceleration, which also should be given to you. Um, I'll double check again whether given to you or not. I can't remember. Sorry. But the value that you learn is 9.81 meters per second squared. Okay, so free fall, any object that falls freely, means it falls under the influence of gravity only. That means no air resistance. Yeah. This you use this value. Okay, so you use the same formula. So you don't panic. Oh my God, teacher! I don't know how to do free fall calculations. Hello, same formula. Okay, so don't no excuse. All right, you know this. You got this. Okay. The only thing additional that you need to know is to remember if the object is being dropped, then the initial velocity has to be zero. All right, that's the additional information that you should know because sometimes the question doesn't tell you this. You are expected to know this. This one is like you sendiri fikir, okay? Sendiri know, okay? All right. Okay, so that's the calculations. I think calculations, if you know how to use this, no problem, correct? Just remember that initial velocity is at the top if the object is being dropped. If the object is being dropped, u is 0, then s is the height at which the object is falling. From not falling now, let me rephrase. This s displacement is the basically the displacement, the length of how to explain the length which the object goes through as it falls down. Okay, the rest you know lah. T you know, V is at the bottom of the motion, A is this one. That's if the object is falling down. I'm going to slide number 9, guys. Okay, if the object is being thrown upwards instead, so let me draw it here. Okay, then this one is slightly different. We did a question like this in the workbook, remember? Okay, remind you again. So when you have an object that's being thrown upwards, okay, if it's being thrown upwards, okay, it's being thrown upwards and it falls. All right. When an object is being thrown, you have to see the question also. You must observe the question. Okay, if the object is just being thrown upwards and they don't even talk about dropping down, if it's just being thrown upwards, then you just consider the going up as one motion. If it's going upwards, the acceleration is not 9.81. How much is the acceleration? Oh wait, I just read Nadia's question. Chel, what does G stand for? What do you think? Gram? Okay, I'm going back to slide number 8. I didn't explain this in class. Maybe I didn't, and I just assumed you all know because I thought you learned before when you were in lower secondary. G is for good game. Not gravity. Gravity is a concept. G is a physical quantity. Okay, G is gravitational acceleration. All right. Okay. Hey, okay or not? Can you just type okay? Thank you. Hey, how come only a few people saying like writing and the rest of you I got like 30 people here. Alamak, where's everybody else, man? You all just sitting there watching and laughing, right? Yeah, I know you guys. Normal. Thank you. Thank you for those of you. Using phone a bit mafan. Okay, no problem, I understand. No worries, Jinja. Okay, so G is gravitational acceleration. So if I'm going back to slide number 9, you guys, if the object is being thrown upwards, how much is acceleration? How much is the A if it's being thrown upwards? Uh-oh. Tomorrow class test and don't know the answer. Negative 9.81. Yeah, yes. Good. It's negative 9.81 because remember I mentioned this in the work when we're doing the workbook question, right? If do you throw an object upwards, gravity the gravity is still pulling it down. That means gravitational acceleration is still attempting to pull it down. But the object is going against gravity. However, the gravitational acceleration is very strong, right? So that's why whenever an object gets thrown upwards, it slows down. When it goes all the way up, finally it slows down, it comes to a stop before it starts to fall down again. At the top of the motion, at this point, velocity is zero. Which means that when you first throw an object up, there is an initial velocity, there's a positive value going up, it slows down, so it's decelerating. And it's decelerating with the value of gravitational acceleration. That's why the number is negative 9.81. So please take note, okay, everyone, please remember this, okay? If the object is falling down, okay, it's falling down, ching, right? What happens is when it's falling down with gravitational acceleration, then this one acceleration is positive 9.81 meters per second. So if an object is thrown upwards and then falls down, these are two different motions. So you cannot calculate both at the same time. You must split this in. Oh my god, it's chachated. Wait, sorry, the line is not in the center. Miss Ho not happy. Okay, line is still not center, but you know what? Let's just go with it, okay? So yes, so that means when it goes upwards, it's this situation, all right? And when it falls down, it is this situation. So when you have a question which tells you the object is being thrown upwards and then falls down, remember that these are two different motions. You split into two, solve each part separately. It's just that because it going up is negative 9.81, falling down is positive 9.81, the motion upwards and downwards are almost the same. The only difference is the direction. So the velocity here and here will be the same. Here, velocity will be zero. Because you think about it, when an object is thrown up, comes to a brief, it looks like it comes to a brief stop and then falls down. Because he has to stop before it changes direction, That's why at this point, the velocity is zero. So if you look at motion number 1, means initial velocity, however much it is, it's a positive, whatever positive number here, right? At this point, the final velocity is zero. If you look at number 2, motion number 2, now initial velocity is zero. The final velocity here will be the same number as what was on this side. Okay, the displacement also will be the same because makes sense, right? Everything is the same. Time also will be the same. It's just that the directions are different. That's why the A's are opposite to each other. Do you understand how to solve if it's calculation? You use the linear motion formula. Okay? Good. Next, I'm going to slide number 10. I didn't cover this in class, but I did throw a question in the class test worksheet. Class test practice worksheet. I don't know how many of you understood, but I'll just go through, okay, just in case. If, right, you were asked to plot a graph of velocity time of an object free falling, you would get A linear graph. Okay, it's a straight line. I know it's not straight. You imagine it's straight, okay? Yeah, it's not straight. Oh my god. Okay, look, the you know by now Jamboard doesn't allow me to draw a straight line. So imagine it's straight, okay? This one, straight line. Picture right, straight line here means it's straight line, okay? Okay, so it's a straight line. Question is if we change the mass of the object, let's say this is for object one lah, okay? Okay, I write here object one. Okay. So this is object number one. This is for number one. Okay, this is showing you free fall. So why is it a straight line? Because remember we already know that velocity time graph gradient is the same as acceleration. Okay, gradient, remember velocity time graph, gradient is the same as acceleration. Okay, so if this is a free fall graph, that means the gradient is the gravitational acceleration. Do you guys understand or not? Again, velocity time graph, gradient is acceleration. So if it's a free falling graph, that means the gradient is the gravitational acceleration. Does that make sense? Yes. So if we change the mass of the object, let's say I got another object. Okay, so this one is, let's say we drop, okay, this one we drop a mouse. Okay, so this is a mouse. Okay, this one is an elephant. Okay, so if we drop the elephant to get, and then we also want to check what is the free fall graph for the elephant, do you think there'll be a change in the shape of the graph? Yes or no? No. Okay, so same shape lah, right? That means this one, the graph will be straight line. This graph also straight line. Question: will the gradient of the elephant graph change or not? Do you think the graph will be like here, same line, or maybe here? So which one? Let's label this as A, B, C. You think which one for the elephant? B, B, A, B, B. Okay, yeah. Okay, teacher say yeah, you're like, yeah to what, man? Oh my god. Wait, let me rub because got line here, teacher don't like. The answer is B. They will still be the same. Okay, because remember that the mass does not affect the gravitational acceleration. So when you drop objects that are free falling, where air resistance is not a factor, they will fall with the same acceleration. So both objects will fall exactly at the same time, same rate. So those of you who got B, you are the bestest. B for bestest. Okay, cool? Understand? Cool. FYI, for your information, I'm going to slide number 11. Just to let you know, sometimes if you may come across certain questions, right, where the velocity time graph for let's say they may throw an object up, an object may fall. Sometimes they want to plot this kind of motion in the same graph. Then you're like, huh? How to plot the same kind of motion in this kind of graph? Remember, this is going up, right? So they may draw. Let me think. How they sometimes draw. Sometimes okay. Here in this case, because it's going up, the velocity is decreasing. They may draw like this instead. Velocity time graph. You see, you have to understand why. Makes sense, right? Because it starts with velocity here and then ends with, I told you here is zero, correct? So during this first part of the motion, wait, hello. Okay, first part of the motion, okay, velocity is decreasing, correct? So then when you look at the second part of the motion, um, this is a velocity graph here. That means you have a positive, you have negative. Because it's going up, positive velocity will change direction, negative velocity. Some people think it's like this. Okay. I know it's time's running out, so I'm just going to tell you this is wrong. So don't do this. So I'm going to rub this off so that you don't look at it. And teacher, why got X there? So it's wrong. It can't be going up that way, even though it's increasing velocity, because you must remember that velocity is a vector. So directions are important. So if you do this, let me draw again to show you. If you do this, it means that it's going in the same direction. Means it's going up, slow down, continue going up again. That's what this second part means. So if you want to correctly show the second half of the motion where it's falling down, it's a negative velocity because it's going in the opposite direction. That means it's actually this way. Does that make sense? I am confused. Duh. You forgot your D. D for Dickens. No, sorry. That's English grammar. Now my English is over already. Look, what happens is if this is going, you understand number one, right? You understand why this is number one, right? You understand why, right? I'm confused. Sure, why? For one, why the graph going down, the velocity, remember decelerating, right? Velocity increasing or decreasing, Caleb? Joe, why is one positive but going down? Same question I asked Caleb. Velocity increasing or decreasing? So here's where you are confused. You are thinking of gradient. It's negative gradient but positive velocity. What on earth does that mean? It's going up, so upwards is the positive direction. So you see, right, positive means what? On the graph here is 0, here's positive, here's negative. Anything above 0 means it is going, in this case, is going up. Means going up. We are assuming it's going up. This one means going down. Depends on the question. Sometimes going down can be positive. Sometimes going down can be positive. Like if you go to slide number 10, when we dropped the mouse and elephant, we took going down as positive. It's possible and correct. Cannot say, oh, but teacher, going down is negative, right? Positive. Can, okay? There's no such thing as positive must be up or positive must be down or positive must be right, positive must be left. There's no such thing. It depends on how we set it. So it's possible for down to be positive. But if you go to slide number 11, the question here is different. Different question. We're not dropping mouse and elephant this time. We are throwing, okay lah, we throw, what you want to throw? What object you want to throw up? Okay, we want to throw a cat? Okay, we throw a cat, okay? This is a cat. So got whiskers, okay? Cat, okay? Okay, looks like a mouse, but never mind, it's a small cat. So you throw the cat up. What happens is up is the up is the direction going up, right? Positive is going up, lor. But as you throw up, the velocity is decreasing because it's going against gravity. So like Caleb wrote, decrease then 0. Yes. Emma, initial velocity isn't 0. Remember, if you throw an object up, when you throw an object up, initial velocity cannot be 0. If this is your hand, and you're holding the cat here, okay, when you start to throw it up, your hand needs to push the cat up, correct? Your hand is moving with the cat. So as you push the cat up, the cat is moving with your hand. Your hand is moving, your hand is not initial velocity. So when you push the cat up, the cat has the same velocity as your hand, That's why the initial velocity is not zero. You're pushing up with a certain velocity, then as it's moving, then it slows down at the top. Yeah? So the graph will be going down, then go up lah. Wait, Cher, why is it positive again? The cat won't die. We're not throwing it off the cliff. We are throwing it up. We will catch it again. Okay, it won't die. It's positive because in this question we're taking up as positive. Okay, we take up as positive. Positive and negative is merely constructs that we set um, to help us solve questions. We can take going down as positive, we can take going up as positive. But you also need to look at the question. Like in this question, normally like this lah, how to understand? Our initial direction is always our positive, normally. So like let's say for example, if you look at slide number 10, if there's only one direction, okay, only one direction, that direction is our positive direction. Okay, but if you go to slide number 11, macam, why is it so confusing? Then, okay, put everything one side. First, just look. Okay, initial direction was what? Going up. The initial direction is up, that's positive. Anything that, if you go, you find that if the direction goes opposite to your initial direction, that becomes negative. Does that make sense? Yeah. So the graph will not be going up again because direction number two, when you catch the cat, please catch the cat, okay? You guys, when you, like Serena, I know got 8 cats. When you throw your cat out, you must catch it, right? So when it's going down, it's opposite to the initial direction. That's why it's negative direction. Teacher, how if when the negative part is decreasing speed? If negative part is decreasing speed, then the graph will go up. I'll show you in a moment. Okay, I'll explain one more time. See, here's positive, drop down to 0. This part is 0 going down to a negative number, right? Let's assume, let's say, for example, I give you some numbers, okay, to understand. Initial velocity you throw your cat is, let's say, don't so fast lah, poor thing. 2 meters per second you throw up. Then it goes up, it becomes 0. This is the cat here, okay? Oh no, why you throw me up? Then you catch back again, it will come back to 2 meters per second. So here would be 2. Here would be -2. 0 to -2 doesn't mean it's slowing down. 0 to -2 means it is increasing speed opposite direction. As long as it's a vector, it goes to negative. Yes, Afif. Negative in physics does not mean less than 0. It's not the same as maths and at maths. Negative in physics means opposite direction. That's why, right, even your acceleration here, okay, the deceleration value I know can be confusing. Negative 9.81 can mean slowing down, but can also mean increasing acceleration in the opposite direction. So maybe I don't go into that lah, unless you lagi more confused. Then tomorrow you cry, you cannot solve class test. So maybe I won't talk about, maybe won't stress so much on this. Just think of it this way lah, for velocity, for velocity. Don't talk about acceleration lah. Till you cry, then this will be very sad. For velocity, negative means opposite direction. So if there's two directions, the positive and negative will be terbalik too. Yeah. Slide number 11. Can you kind of get it? Okay. I know that this is like, you're now like lying on the floor, staring at the ceiling, and then you're wondering, like, why me? It's, okay, to simplify, over here, Okay, again, just think of it this way, yeah. Positive, negative just means directions. Okay, so you find that when you throw the object up, it slows down. That's why two drop to zero. The second direction is zero increase to two. Zero increase to two. But why we don't put this way? Why we don't do this? Because it's opposite direction. So that's why it's actually zero to negative two. That's why it drops straight down this way. Okay, that's why we don't do this. Does that make more sense? Okay. So even though you see, why one straight line, teacher, I thought it's two different motions. It's because of the directions. Okay, just think of it that way. Two different directions. That's all. Positive and negative, because it's a velocity time graph. It's a velocity time graph. Sure, if you have to plus, you have to recalculate this, then must do separate, then plus together. So actually, if I put the first point negative 2, then the other one will add 2, right? Yeah, question first. If we have to calculate, then must do separately, right? Then plus together. Yeah, that would be better. Depends on what you want to calculate, though. Like if you're counting the acceleration, then you count, that's, well, it's one straight line lah. So the question, so it's pretty much the same acceleration value. So yeah, if you count for one and two, so it's the same acceleration. But if you have to count displacement, then you count for one separately, then two separately. Sure, if I put the first point negative two, then the other will add at two, right? Yes. If it was the other way, yes. That means you if you took down as positive, then you're correct. It'll be negative, then positive. So it'll be a straight line going up instead. Any other questions? No. Okay. Last bit, super last bit. You've already learned this. You can go and review again. In the PowerPoints that I did with you in class. Slide number 12. Just the super last one. Remember the comparisons, yeah? Situations A, B, and C, the one that I talked about. So if you drop two objects, I'm drawing shapes here because you know Miss Ho drawing the very third one. So remember that if you drop them in air, if air resistance is not a factor, that means air resistance is negligible. It's negligible when the mass is greater than air resistance, significantly greater than air resistance, both fall together. If you drop something, like let's say, okay, like this one is maybe like the coin and pencil, coin and eraser kind of thing. But if you drop an object, like let's say coin and feather, okay, this is feather because this whole can't draw, so I will put here feather, okay. This is feather, okay. This is feather. So yes, when you drop it like that, then what happens is one will drop straight down, the other one will don't know go where one, right? That's because of air resistance that's acting on the feather. If you drop the coin and the feather, like you know we saw the video, right? That one where you drop the where you didn't drop it lah. Okay, they dropped it. They dropped the bowling ball and the feather in vacuum. When then they fall together because again there is no air resistance. So just be aware lah of these three situations also. Okay. Any other questions? If you really want to review this recording again, I will share the recording in GC once I've uploaded it. But I also share the Jamboard lah, alright? So that at least because in case I know you don't want to watch the recording, like, oh my god, who want to watch 1.5 hours recording? So I'll share the Jamboard also lah, so you just pick the Jamboard, alright? Yes, essay questions, it's like the one that we've been discussing in class. You remember we had three essays we went through. Look, your essay question tomorrow obviously is not any of the ones I gave in class. Okay, you have to test you all on what you know. But just remember, use your logic. Remember, you must give the suggestion plus reason. Okay, suggestion plus reason. Stick to characteristics. Don't give me material name. Don't suggest, oh, plastic. Teacher use nylon, use wood, use cardboard, use rubber. Don't want. You tell me low density or low mass. Okay, stretchable, flexible, stuff like that. All right. Vacuum means no air resistance, but does no air resistance means in vacuum condition? Uh, if it's no air resistance, then it's vacuum. If there is air, but like the first one, it's negligible air resistance. Do you understand the difference? Okay? Negligible means got but can ignore. No air resistance means got no air to fight against the object. That's why it's vacuum. Teacher 10 mark how to do. So we answer in table form for the essay questions. You only answer table form for the 10 mark question. The others, like the 2 marks, 3 marks, 5 marks, you write. You just write in sentence form. If you are not confident about drawing in table, if you are not confident, I still accept for now. You don't do in table, you write in sentence form, I will still accept. But you must make sure you have all your 10 points. Okay? Your 5 pair of information. Suggestion plus reason. Okay? You don't want to do table, it's okay. I accept. Can. I accept in paragraph. But you make sure you have all your 5 pairs of information, or 5 pairs of answers, okay? Your suggestion plus reason. Okay? Oh, remember, always make it easier for the examiner to give you marks. If you make it very hard to read, examiner can't give you marks. Like imagine in maths, you write the formula, but you took the photo so small, then the examiner can't even see whether it's a 2 or a 3. How to give you marks? Always make it easy for the examiner to give you marks. That's the trick on how to get more marks. Yeah, I think we call it a night. It's already an hour and a half. That's so much longer than what I expected. So I'm sorry that this took longer than what I expected. I hope you found this helpful though. Okay, bye. Good night.